A key component that makes this virus and this pandemic so challenging is that so many people who are infected with SARS-CoV-2 are asymptomatic, so you have that spread continuing without any knowledge of those symptoms. So our surveillance testing here is designed not to eliminate the presence of the virus in the cadet wing and the permanent party that are supporting the cadet wing, but to identify it early enough that we can pull those particular nodes out, remove them from the population, put them in quarantine or isolation, and enable to sustain and support that operation continuing.
So back in March, actually, with Dr. Rohr and then a couple other microbiology, virology types in the department, we tried to figure out if we could bring the technology to detect SARS-CoV-2, so the virus that causes COVID-19, in our labs.
We sort of initially started as the biology COVID-19 research team, where we were trying to sample the cadets before they went home last year.
The real key component came when we paired the biological expertise that I have down here with the math expertise and the modeling expertise from across the institution.
It turns out that there's a set of differential equations that govern how diseases spread through populations. And we can use the same tools that we use for analyzing how aircraft fly and model what would happen with SARS-CoV-2 in the specific context of the Air Force Academy.
The true power of the multidisciplinary approach of the pandemic math team was unleashed and enabled us to provide a path forward to not only bringing our entire 4,000 plus cadet wing back to USAFA in person, but then how to sustain academic and training operations from there on out.
So we realized that there was kind of a magic test point, a magic testing rate, and you can estimate what level of testing you have to do, not to find all the virus, but to find enough virus that it never grows exponentially. And so we called that the Fizzle Equation. Essentially what happens is that the virus does not grow exponentially, it just burbles along at the same constant rate. It fizzles out. Any nascent outbreak fizzles out before it has a chance to get going.
Week to week, the number that we test can vary. We do try to shoot for about a 4% of the cadet wing. It works out to about 200 or so a week. My role is kind of morphed into helping create the test lists each week, and so I spend some time working with spreadsheets and actually talking to folks in the med group and in the cadet wing in order to try to make the most efficient test list that we can.
The process as we come in, the lists are generated, samples are collected starting at about 7:15 in the morning. As the samples are collected, they are pre-batched and pre-identified in a particular pool, so the cadets and the permanent party are identified already in pools of 8. As soon as the collection is complete, the med group, they're keeping those samples on ice.
Every morning we get the samples from the 10th Medical Group. We have a walk-in fridge. We take the samples, we check to make sure that all of the pools are correct. So as we're going through, we're looking at each tube, making sure that if it's in pool 101, that all of the tubes in there are for 101. Once we get them, we take them to the hood over here, and we do an RNA extraction. So that's simply taking the virus inside the cells of the sample and then taking it out so we can get access to the RNA. So once we have access to the RNA, we use the thermocyclers to turn that RNA into DNA and then amplify it. So if there is a single virus particle in there, or RNA from a single virus particle, we make a copy of it. So now you have 2, and then copy, so you have 4, until it brings it up to a detectable level, which then the thermocyclers give us a reading of approximately how much virus is in your sample.
Anybody in a presumed positive pool, all those samples are then evaluated individually and run individually clinically. A key component in this process is that a single sample, so that one swab that is collected by the med group in the morning, we use that sample both for the pooled surveillance testing, and then if there's a presumed positive pool, that same sample can be used for the individual clinical follow-ons. As we began the surveillance testing early on with just faculty members, from the biology department perspective, we have a lot of cadets who are familiar with and adept in running PCR. Once we get past that infectious point and preparing the samples when they're no longer infectious, that's when we bring the cadets in.
I'm Cadet Second Class Megan Doherty, class of 2022.
My name's Zach Beatty. I'm from the class of 2023. We're in charge of the training, the recruitment, and overseeing all of the cadets.
This has been an incredible opportunity to get a real-world application experience.
I think it's amazing how we're able to have hands-on experience and actually helping with this testing.
The best part, honestly, for me is to watch the cadets get excited about it. You try and get them excited about PCR in class and they're like, yeah, okay, we get it, you're making more copies. But then you show them that it's for a COVID test and you tell them how to do it, and then all of a sudden they're really excited about it. And that is what I think is the most energizing part, getting the cadets excited about it, getting the university in general excited about biology and the power of biology.
I think if you were to look at the Air Force Academy, you would have to say this is probably one of the models for the whole country. We have the facility, we have the expertise, and we started early asking questions. What can we do? How can we keep it safe for the cadets? How can we make it better for the cadets? And how can we manage this pandemic?
This is really kind of a unique enabling environment where we have so many incredible different subject matter experts across the disciplines in the same building, not necessarily constrained by the normal staff structure.
As we were putting together the pandemic math team, it was very easy to say, well, you know, we probably need a microbiologist, we probably need a virologist, we probably need some statisticians, we probably need some mathematical modelers, we probably need some database folks. And so it was very easy just to look around the academy and say, well, we got that, and we got that, and we got that, and we got that, and to pull them together in a team. So you put a lot of smart people together that are mission oriented into that situation, into that context, and you're going to get good results.